All right, now let's take a look at pandas. So, pandas is a two-dimensional uh, object. So, pandas is a open source library that is very commonly used, well used with Python, and it creates an object called the data frame. The data frame is typically a two-dimensional object. So it's kind of like a list of lists in Python. It's kind of like a NumPy array. It's kind of, you could, some of the things that are different about it than the NumPy array is the columns can be referenced by the name of the column. So that makes it look and feel a little bit like a table in a database where we think of the columns as the fields and have field names. So you can refer to a column in a pandas data frame by its column name when you're doing your indexing and slicing. Um, And so it's kind of similar to a CSV file, right? CSV files, a lot of times we have a column name. The first row of the CSV file is a column name. Not always, but it can be. So it's kind of like that. It's different from a NumPy array in that the data type of the information can vary. So it can be a whole mixture of integers and strings or whatever. So in that way, it looks a little bit more like a database table as well, right? Because a lot of times, if we had a customer table, we might have numerical information about the customer and we might have string information about the customer and things like that. Might have their name, maybe age, date of birth, right? So different data types. And so the pandas data frame holds that. So for a lot of business uses, a lot of times we're extracting data from a database about our sales or something like that, and it's going to be a mixed data type, and we can bring that into a pandas data frame. And we may be using the string variables as categorical variables in our data analysis and things like that. So let's take a look at the pandas data frame. Again, like NumPy, it's an open source library. We're going to import it. It's already installed in the Colab. And then that data frame will have a bunch of methods for manipulating the data, doing analysis of the data. Um, we can do all our indexing and slicing that we did with other pieces of data as well. The indexing and slicing syntax is different for a pandas data frame than it is for a Python list of lists or a NumPy array. Um, it doesn't, it's not difficult, but remember, whichever of those objects you're in, your slicing and indexing is gonna vary between the objects, which makes it a little confusing. Like, hey, what am I doing here? And so you might have to look. As far as learning this, I'm going to do the same thing, similar thing as I did with NumPy, and I'm going to show you a couple little things about the Pandas data frame, and then I'll send you to the Pandas site for some of their stuff. Let's see. Oh, one thing I want to point out, another difference between a NumPy array and a pandas data frame is the NumPy array is immutable. That means if I want to change, say, one number in it, I can't go into the NumPy array and change that number. I have to make a copy of the array with the new number into a new variable, and it's really a copy of the whole array with the number changed. And that's because it's just in certain spots in memory. With a pandas data frame, it's a mutable object where I could go into one cell and change the value. So just a slightly different syntax um, when we're making those changes, if we're changing the data. Um, with the NumPy array, maybe the NumPy array is giant, and copying it could actually be time consuming depending on what you're doing. All right, let's look at a little example, right? Import pandas as PD. So, right, again, industry standard is to import pandas as PD. PD means rename the pandas library as just PD to shorten it in our code. And so we'll always use PD for pandas. And then we say we create PD dot data frame within the PD or pandas library. We've got a function called data frame that can convert this list of lists into a data frame with the columns having column names to them, right? So inside here, these brackets, that's just a list of lists. It's a Python list of lists. The data frame function is going to convert the list of lists to a data frame, which looks almost the same to us, but it has to be made into a data frame before data frame methods will begin to work on it. And then this columns, because like we didn't see this when we had the NP array, because um, in an NP array you can index the columns, but the columns do not have a name, right? So instead of A, this could be like first name, last name, age, or something like that in pandas. And then we printed out the columns for A, B, and C. 0 and 1 are just the indexes to the rows, and the data in the rows is given here. All right. So since columns have names, we can, we may make this data frame here. We give the columns names. So it's really just a column name here. It's where it says row label. But it's really nothing special here other than we call the name of the first column is row label and the name of the second column is A. And if we want to print data frame column A, we would use this syntax here. And you can see we're just indexing on the name of the column rather than 0, 1, 2. We can also index on number, but we're indexing here on the name of the column. So that's a new thing, right? A Python list of lists or a NumPy array would not have a name of a column. And so you can see we're printing those out, right? Column A is our second column, so that's why we get the 0, 0, the 1, 0, and the 2, 0, 0, 0, 1, 0 gets printed out here. All right. We're using the print data frame column A. And just to give you an example of a method here, right? So we take data frame column C, okay, dot as type, interpret the data in column C as floating point dot, and take the mean of all of those numbers. So we're doing kind of two methods here on the data frame, and the answer is 12. So we convert to float and do the mean. If we didn't convert to float, it would do the integer mean, and it wouldn't tell us if there were something after the decimal. It's not really needed in this example, but okay. But the point is df is our data frame. Again, that data frame was defined way back here. df equals pd.data frame. Okay. So that's what a data frame is. It's a new class. It's two-dimensional. Its columns have names, and there's a whole bunch of methods that can do analysis of that. And so we'll send you to the Pandas website for more detail. There's a bunch of stuff on it and a bunch of tutorials, and there's kind of like more than one start here thing, which is confusing. So these are the pages I picked out for you. Is these, and actually these are very short, but these are kind of the level of memorization. You almost should memorize what's in these few pages. So I'll click on one. So what kind of data does Pandas handle? and then it's going to send us here. And you'll see all the tutorials that I picked for you are from this list here, and what kind of data, right? And it kind of explains this. So this, I've really covered this, but take a look at it again. The copy button here lets you copy the examples to your Jupyter notebook. So definitely copy a couple examples, change up the examples, see what it does, and that's a good way to learn it. So the ones I say are kind of at the memorization level are these six, and they're pretty straightforward, and they're pretty short. So I know but if you see sort of other things in here that look interesting, that probably will not, but you can do that. All right. So have a look at that and let me know how it goes.